And I'd like to introduce everyone to Tom Cole, a solutions engineer. It is great to see you, Tom. I'll be joining you for some Q&A after the presentation. Looking forward to that. So please take it away.
Thanks, Keith. Very happy to be here today. And what I'd like to discuss with you now is Keeper's next generation privileged access management. So first of all, just a few quick statistics just to outline why we're here today and what the main problems is that our solution is addressing. So first of all, stolen and weak passwords are the leading causes of data breaches for an organization. However, most will have very, very little visibility or control over their staff's hygiene in this area. And this creates a massive hole in the organization's security posture. And it could be so easily fixed with an effective password management system in play. Now, when organizations do get this level of visibility, quite often what they find is that a large portion of their users' passwords will be both not complex and also reused across multiple applications. Now, this second figure here in regards to that 62%. So 62% without a password management solution in place is very, very difficult to provide a secure way to share credentials that doesn't involve a plain text approach. And even things like sharing credentials through like Slack or Teams or other instant messages, you're still sending across sensitive data in plain text. And that final statistic there, 99% of attacks that could be prevented with 2FA in place. And the main problem around the 2FA is that a lot of users will actually see it as an inconvenience, disrupting their workflow since they have to go through their second device to generate the code instead of that additional layer of security that it's actually providing. And taking these three figures into consideration, some real good food for thought here is that while a lot of organizations will only offer a password manager to a specific team, specifically teams that have a higher level of access, really all users become part of the same chain, just with varying degrees of privileges. And what I'm hoping that the main takeaway from today's session will be is how Keeper can protect against all the above scenarios and no longer just in a traditional password-based approach, across your development and your virtualized environments as well. Onto the secret side of things. So if we think about a typical development environment, and in particular the DevOps who are responsible for it, so they will be managing and also utilizing a large number of secrets day in, day out. And for a developer, their main focus will really be the availability of the systems as opposed to the actual security behind it. Quite typically, what we see happening is that secrets, such as your API keys or passwords, they get stored all over the place. And quite often, this will mean that the secrets may be hard-coded into the development platform itself, or else stored inside the platform's very own independent secret manager, creating multiple different points for failure. Again, since developers will be using multiple different platforms, the risk here grows considerably each time. And even just taking security out of the equation here, a simple password change inside one of these production environments can run the risk of bringing down all these different builds because the developer themselves will have no clear visibility into all the spots a secret is being used, and the process of actually doing that update is quite manual as well. And the third component that we're talking about today is connections. So if we think of traditional PAM solutions out there, and their main goal really is to allow a simplified means for users to access different environments but in a secure manner. And the solutions themselves will be able to facilitate the creation of secure connections through different protocols such as your SSH, RDP. And unfortunately, this does come with quite a heavy trade-off. And the main problem that organizations find with these solutions is a very long and complex deployment stage. For example, things like setting up secure connections, integrating with your existing infrastructure, and configuring different access policies can all be very challenging and a very cumbersome process overall. So the kind of traditional PAM solutions all need to integrate seamlessly with these different systems, such as your operating systems, databases. So overall, while the goal is quite a desirable position to be in to have this working PAM solution, the pathway to actually achieving it is one that a lot of organizations simply won't have the time and resources to reach, even with the traditional software in place. And this pathway can be made up of a lot of different components. For example, not enough budget for the required PS hours, which is essential for any legacy PAM solution. Without that PS, very, very difficult to provision alone. And then along with having PS for deployment, This same PS will also be required for the onboarding and training of your staff, which again is a very difficult thing to achieve alone without that kind of resource in place. So when we take these different downsides into an account with the traditional PAM solutions that we all kind of know from over the years, it points to three very common themes across this space. And the first one there is that solutions are far too complex for most organizations' use cases, and they really need to be simplified down. Also, while they are very comprehensive solutions, quite a lot of the features themselves remain unused by the majority of users. And then thirdly, like we discussed earlier, additional dedicated resources required to actually manage and maintain the solution itself. So mainly pointing towards traditional PAM solutions not being very cost effective for many organizations, both in the cost for the actual product and the additional personnel that are required to manage it. And this brings us on to Keeper's PAM offering, or Keeper's next generation PAM solution. So Keeper's PAM was essentially designed for today's environments and with the three main pain points that we just discussed on the last slide taken into consideration. So what this means is that it combines the three most critical components of a PAM solution: secrets manager, the password management and the connections, minusing the high costs, excess features, and the complexity that is attributed to your traditional PAM solutions. So what I'd like to do now is to just give a rundown and a high level overview of those three core components that we have. First off, Keeper's Enterprise Password Manager. So this gives you full visibility of your user's password hygiene across the entire organization, and also a very easy means to improve. And it does this by providing each user with their own secure password vault that can be accessed from any device in any location. We're also a fully zero-knowledge solution. This means that all the data that we store in the cloud is encrypted text or it's deciphered text, and the key required to decrypt this information is all generated and stored locally on your end users' machines. Keeper will also integrate very easily with all the main IDPs to allow for single sign-on and easy user management from the administrative side, and the IT admins can also enforce different policies for things like password complexity, sharing, and also run reports to gain full visibility across the organization. Now, what I'd like to do now really is just to give a quick demonstration of the tool, and specifically what I'd like to focus on is the different types of data we can store inside the vault, how information can be very easily shared, how Keeper can notify you of any breached passwords in use, and finally, how admins can gain visibility across the organization. So I'm just going to cut across now to the Keeper Password Manager that we have right here. And first of all, just to discuss the different types of data we can store. This will really range down to the different record types we provide. So it's very comprehensive, comprising of your traditional logins, PI, file attachments, server credentials. Anything that you wanted to create that isn't stored in this list, Keeper also provides very granular options to create your own custom record types from scratch. And to just show you what that flow would be like for creating a traditional login, Keeper provides the username password fields. You have Keeper's password generator to guarantee that you're no longer using pattern or dictionary based passwords. You can choose the full criteria for this here as well. And then also, any sites that leverage 2FA, we can very easily upload the QR code to Keeper. And what that will then allow Keeper to do is to generate the 2FA code for that site login for you as well. So again, removing the manual process that users previously had to go through to leverage 2FA. All these logins can then be very easily auto-filled from the Keeper browser extension that we have right there called KeeperFill. Secondly, how we can utilize Keeper to securely share information across the organization. So we have three approaches for taking this. First of all, if we look at an individual record right here, what we can actually do is we can share it out to somebody or multiple users by typing in the email address of those users in Keeper. Here's what level of access they have to the record, and that record information will now appear inside their vault. To revoke access, we can just delete it from the user's vault at any stage, just by following that step there. We also have the ability to create a direct URL to a record, so that even if somebody doesn't have a Keeper account, or if I just want a secure way to share information across to somebody, I no longer have to do so in plain text. And then lastly, Keeper also provides shared folders, which allow us to share a whole bunch of records out in one go to different users or teams And these team structures can be created manually, or else they can be imported directly from your AD groups that you would have. Lastly here, how Keeper can notify you of any breach passwords that you may have in use. So we actually have a feature in here called Breach Watch. And how this works here is that Keeper has access to its own dark web database that we built and we maintain it. It contains anywhere from 5 to 10 billion passwords inside, all one passwords that have been used in data breaches in the past. And basically what we do, because we're zero knowledge, we can't see your data. So we compare a hashed version of your passwords to a hashed version of that database with the same algorithms. Once we see a match, we flag it in here, and it's a nice proactive way we can identify any breached passwords in use. So that is essentially it in terms of the password management piece. I'm just going to cut back in here to the presentation and just go to the next section, which is Secrets Manager. So Keeper Secrets Manager, or KSM for short, is a fully managed platform where you can secure your different infrastructure secrets. So with KSM, what we can do is we can remove any hard-coded credentials from your source code or from your config files, instead being able to replace them with environment variables and pulling in the secrets directly from your Keeper vault. And we do this through 3 different methods. First of all, we have native integrations with a wide array of different CI/CD platforms and different orchestration tools. Secondly, we have different SDKs like Python, JavaScript. And thirdly, we also then have a CLI form of the secrets manager, so you can use variable values for any of your locally running scripts that you may have as well. More recently, Keeper Secrets Manager also allows you to automatically rotate passwords. This can be done across your different devices like your Windows, Linux, Mac, databases, AD users, cloud-based services, and rotations can be either carried out ad hoc or on a scheduled basis. So again, just to pop very quickly into the tool here and just to demonstrate 2 of the main areas of this solution. So first of all, how we can actually leverage secrets inside your Keeper Vault within a development environment. And again, we're going to go back to the Keeper Vault to do this. So first of all, there's 3 core components to Keeper Secrets Manager working. First of all, shared folder. And a shared folder here will be essential to store in your secrets that you have, like your API keys, your database passwords, server credentials. Secondly, an important factor is that each record in Keeper is attributed to a record UID. And that record UID is what we would use inside the development platforms themselves to pull in variable values for those specific secrets. And the third piece here would be your Secrets Manager application. So this is one that I just created yesterday just for the purpose of this call here. I pointed it down to that specific shared folder. If I wanted to add in a new device, so I'm just going to call this one here my new, for example here, my new GitLab device here, okay? And I'm going to generate out a config file here, which will be a base64 encoded string. It's going to look something like this. And that string now acts as a bridge between this specific shared folder in my Keeper Vault and the development tool that I want to use. And as we discussed, we have 3 main ways of leveraging those: native integrations, our SDKs, and the CLI form there as well. And just to show you a quick example of how that would look, if I wanted a secure way to leverage this Windows Server username and password, I will just make note of the record UID, fields I want to extract, and if we go into, like, say, GitHub here, for example, I can then add this piece here into any actions that I'm running, record UID followed by the field and the variable value. So going forward, any time that I want to use that Windows Server credential inside GitHub, I no longer have to use that username or password in plain text. And then secondly, in terms of password rotations, how they work through Keeper as well. Again, this would also be leveraging through Keeper Secrets Manager. We would create an application. Inside that application itself, we would deploy a Keeper gateway. The gateway is designed to perform the actual rotations itself, and it will be deployed inside your environment. And the main purpose of the gateway is that it can communicate with the machines that need to have the password changed. So inside Keeper, we can now create records for devices that I want to change the password for. So for example, a very common one there would be your Active Directory users. All that is required for this rotation to work is the credential here to the AD server itself that can perform the rotations, as well as the PAM user record, so the record of the user account I want to change the password for. And then at any point, what I can do inside Keeper is I can schedule this password change to take place daily, weekly, monthly. I can choose the complexity of the password here, or else I can just run that password rotation on demand by clicking the Rotate Now button. So again, just to go back into the slide here now, and what I'd like to talk about here is the final component, which is Keeper Connection Manager. And this is our remote desktop gateway, and basically it's designed with the goal of simplifying how a user connects to any virtualized environment, while at the same time being able to improve visibility and the machine management for the administrators. So it's a fully agentless solution in that a user just connects to the Keeper Connection Manager via the web browser. Nothing needs to be installed on the targets themselves. And we just leverage the native technologies that are already used to connect to these machines, such as your SSH, RDP, and different database protocols and Kubernetes as well. So what this means first off for the end user is that they have a single pane of glass to access all machines without any VPN connectivity required, and that you as an administrator then have full visibility over all sessions taking place, both in real time and historically, and also you have the ability to assign and revoke user access to these machines as required, while never sharing credentials to the users themselves. So again, for a quick demonstration of this platform here, what I'd like to cover is basically the flow for an end user and how they would leverage the connection manager. And then secondly, how an administrator can use the solution to audit different connections taking place. So I'm just going to pull across this solution right here, first of all. Now, when a user signs into the Keeper Connection Manager, they can do so via username password. We also support AD authentication, authentication through your IDP, like your Azure AD, Okta. What they will see, first of all, is exactly on the screen here, the most recently used connections, as well as a full list of connections they have been assigned by an administrator. Now, no credentials have to be shared with the user when we're giving them access to these credentials, or to these machines, sorry. So that means we have a very, very easy means to give short-term access to these machines without any password information being shared across. In terms of opening the connections themselves, I can open up this Windows server here very quickly. And basically what this will give us from here is just full access to that server, the exact same way as we would have from any remote desktop client that there is out there. Users have the ability to copy information back and forth from the clipboard. We have the ability to create mapped drives. We can see that here, for example, at the download folder here, download folder there. So we can very easily drag and drop files from our local to our virtualized environments. And also to create a sharing profile. So if I wanted to give somebody access to this machine and they didn't have an account inside the Keeper Connection Manager, I could just generate this link for them here directly. Now for the administrative side, an admin gets real-time visibility into all active sessions taking place, like the one that we're in right here. They can join that session where they can commit actions, also quite good from a collaboration standpoint. And also they have the ability to terminate any sessions and end the session whenever that needs to be done for the user. And again, because it's not feasible to be around 24/7 watching these different sessions take place, you also have the history view, which gives us a cumulative overview into every session taking place. So the user, when they started the session, the duration, the machine they connected to, and also down here, a video recording of each session. So this is the session that we were literally in one moment ago. We can watch a recording of this. We can see here that anything that's kind of raised up here is a key event that took place during the session. And we also then have a keystroke log to give us full activity and full visibility across any text that was typed during the sessions themselves. Lastly, users then have the ability to administrate access to these different connections from the user tab, and they can essentially do this very easily by clicking into a user like Dave here, for example, and choosing when they can access the platform in terms of dates and times, permissions they have inside the platform, and machines they have or haven't got access to. These access and permission levels can also be grouped down to your AD groups, for example. And in terms of the connections that we support, if we click into this one here, for example, you can just very quickly see the different protocols that we cover. So your HTTP applications, RDP, SSH, and different databases. So it's quite comprehensive and all the main ones that you would expect to see. And again, just to go back to the presentation here one last time. So just to finish up, there we have it really. So just to very quickly summarize on what we've discussed here today, okay? So first of all, Keeper's next generation PAM platform, what it provides is the core components of a PAM solution without that added complexity, and also a very easy way of allowing your IT teams to very quickly and inexpensively deploy those different solutions. As we saw from the demonstration, it does all this by providing a single pane of glass where users can manage all their passwords, secrets, and connections, and administrators will also then have full visibility over the organization's authentication hygiene. And that is essentially it from my side. Just to say here very quickly as well, if you attend a demonstration of Keeper, we're also providing you with a free 3-year personal password manager subscription. And I think I can see a couple of questions coming in there, Keith, if you want me to hand it back over to you.
Yeah, great stuff, Tom. Thanks so much for that overview. Really important topic, obviously. Not much more important these days, is there, than this kind of stuff? We do have some questions coming in, and we do have time to get to a few of them today. So let's dive in. First question up from our attendees. Are browser-based password managers safe, and are they good enough?
So I would be inclined to say no to this, and the reason I would say no is that any any password manager using for your browser, the passwords will be stored in plain text, whereas Keeper is a fully zero-knowledge solution. That means your passwords will be all fully encrypted, so nothing is stored in plain text, whereas with the browser it will be. Um, Secondly, a web browser, while it's going to secure the passwords, albeit in plain text, it's not going to give you any secure method of sharing the password. So we saw there the 3 different sharing methods that Keeper provides. Um, Again, the passwords will only be available from the specific web browser that you're using. So if it's Chrome, for example, I can log into Chrome from anywhere, but it has to be a Chrome browser. It's not any specific device or browser that I go to. And I suppose lastly as well, Keeper can store anything. A web browser is literally just limited to storing passwords, whereas Keeper is files, PI information, server certs, whatever it is that you have.
Absolutely. Okay, great. Next up, single sign-on SSO. What are the security risks with using that?
So there's a few different points to that, right? So first of all, SSO providers are very good, like your Azure AD and your Okta, and the main pain points I would find with those, right, is first of all, single sign-on is going to be a single point of failure. So if it's not implemented properly, once a malicious user gains access to your IDP login, they automatically gain access to all the different systems. And I know you can kind of say on the other hand, well, isn't that the same principle with Keeper? But it's really not, because all the data is encrypted, and the only way to decrypt it is with the physical key on your actual machine. So an IDP, if you get the username and password, you're in. Keeper, if you get the username and password, you're not in, because you need to have the key. So it eliminates that single point of failure. Secondly, as well, I'd always say that an organization is doing very well if they are able to get all their sites to be supported across single sign-on. So it's going to be anywhere between 50 and 70% of the sites will be supported through a single sign-on. And what do you do with the remaining percentage that are left over? You've got no visibility of the passwords being used, and you're essentially in the same boat as you are without any solution in place at that point.
Ouch. Okay, I think we have time for one more question today, Tom, and it's a technical one. So, of course, it's one that I enjoy. Can KeeperPAM, the product that you did mention in your overview, can that be used to update Windows service accounts? And what they mean is, when the password is rotated in Active Directory, does it go to the machine? Does it go to the machine the service is running on and update it there as well?
It will do, yeah. So one of the components that we have with the Keeper Password Manager and the password rotation module that we discussed is that along with scheduling the rotation, so we saw during the demonstration how you could schedule a password rotation to take place, daily, weekly, monthly, and what you can also attach to that configuration is something that we would call a PAM script. So after the password rotation has been executed successfully and completed, that PAM script will then be ran from the credential that was provided, perform any actions that you require. And the ones you outlined there will be very typical. So things like restarting your different Windows services, and if a password's been changed, making sure that new password gets down to the different Windows services that require it. So yeah, that would be a very common use case that our customers would do with the password rotation module after a password's been updated.
All right, fantastic. Well, Tom, it's been a pleasure to have you on today. Thank you for updating us on what Keeper Security is doing and on the necessity of managing this highly complex field in a way that looks really simple and easy to use and highly secure. So thank you once more for being on with us today.
No problem. Happy to be here.